let's look at the test. First, you were supposed to define the 4 words, experimental error. You should have said something about the difference between what you measured and what you were supposed to get. Or, the things messing up so that it didn't come out exactly what you were supposed to get. Empirical formula is the simplest ratio of elements in a compound. The molecular formula is the actual number of elements in a compound. And a polyatomic ion is an ion made up of 2 or more atoms. That's really all you had to say there. For number 2, you were supposed to fill in the blank, and repeating an experiment several times and averaging the results helps to reduce experimental error was the answer there. Number 3, a student is doing an experiment that stoichiometry says should produce 34.6 grams of product. The student actually gets 25.2. What is the student's percentage yield? Actual yield divided by theoretical yield times 100 gives you the percentage yield. And so we're going to work backwards to figure out how many grams of sulfur trioxide that we got. Okay, we are starting with 750 grams of this. And so we want to know what this theoretical yield is. So we go 750 grams C4H8S2 times line. And we have grams of that, moles of that same thing, times line. We have the moles of that, to the moles of this. Then we can go from the moles of that to the grams of the sulfur trioxide. And so let's put the numbers in. This monster is 120.24. And then, let's see, this gets a 1, this gets a 2. And then this gets a 1, and this is 80.06. And in 4 significant figures, there's 4 here. I don't see, that's 4 also. 999.1 grams of sulfur trioxide. Okay. Now, that's how much you could possibly get. Let's figure out what she got. We know that she got 95.4% yield. We are looking for her actual. We have the theoretical. And so that's how we figure it out. And that gives us an actual yield of 953, 3 significant figures, grams of sulfur trioxide. Now that problem, 4, is worth 6 points. 3 points, in other words, 1 section is here. 3 points for getting that, and then 3 points for getting this. So that's how you would grade that. If your significant figures are off, take off a point. For each step, like if your significant figures are off here, take off a point. If your significant figures are off here, take off a point. Number 5, what is the empirical formula for a carbohydrate? You should have had CH2O. Okay. Number 6, what's wrong with the following statement? Because there are no common factors in a molecular formula, K2CO3 is also the empirical formula for potassium carbonate. And you should have said something to the extent that ionic compounds don't have molecular formulas. Something about that, okay? Or you could have described that they actually make a lattice and blah, blah, blah. You could have gotten real technical if you wanted to. So, number 7, which of these chemical formulas is the empirical formula? That would be C2H4S. Number 8, for the chemical formula in number 7, that is not an empirical formula. What is its empirical formula? And so you divide it through by 2 and you get CH2S. Number 9, a compound has an empirical formula of C2H3O.
3.03. If its molar mass is 300.20 grams, what is its molecular formula?
Okay, so we have the empirical formula as C2H3O3. And so let's figure out what this mass is. So you'd go 2 times 12.00. 3, is it 0.00 or 0.01? I think it's 0.01. Yep. 2 times 12.01, 3 times 1.01, 3 times 16.00, and that's going to give you a mass of 75.05 grams. Now we are told in the problem that the molar mass of the molecule is 300.20 grams. And so when you divide those two, it will give you 4. So you're going to go back, and the molar is going to be times 4 is 8, times 4 is 12, times 4 is 12. And so C8H12O12, and that's why. You divide the molecular mass by the empirical mass, get the ratio, and then multiply through the empirical formula by that number, and that way you get the molecular formula. Number 10, a chemist burns 100 grams of chromium in excess oxygen. There's only one product, and it has a mass of that. What is the empirical formula of the product? Empirical formula of the product. So we have burned 100 grams of chromium, and then the final product has a mass of 192.31, and that's the product. There we go. And it's burned in excess oxygen, so we know that oxygen is the other thing in there. So we know that if we subtract this by this, which is going to give us 92.31, that's going to be the grams of oxygen. And then if we take both of those, we're looking for the empirical formula of the product, so we're going to take both of those to the moles. Chromium, I do not have memorized. Let's see, 52. Alrighty, that's going to give us, in 4 significant figures, moles of chromium. And this is going to give us in 4 significant figures, okay, now we divide both through by the smallest number, which would be that. So chromium's going to be a 1. Let's see what oxygen is. 3. Oxygen's going to be a 3. And so we end up with CrO3 as the empirical formula. There you go. Oh, how does he grade it? Hang on, I'm sure he gives pieces. Yes, he gives 3 points for figuring out the mass of oxygen, so subtracting that and figuring this out. 3 points for this. Oh, excuse me. 3 points for figuring out the mass of oxygen, 1.5 points for this, 1.5 points for this, and 3 points for that. So this adds up to 3 points. So the whole thing is worth 9 points. Number 11. A combustion is done on that many grams of an unknown substance. The analysis produces that many grams of carbon dioxide, that many grams of water. There is no other product. What is the empirical formula of the unknown substance? So first, we have 522.4 grams of an unknown substance. So we're going to put substance. And we have 499.4 grams of carbon dioxide. Oh, and it's combusted. And we have 204.5 grams of water. I'm going to move this down. Okay, so first let's figure out how many moles of each of those we have. Products. So we're going to go times line, grams of CO2, moles of CO2, grams of water, moles of water. Okay, 1 mole 18.02, 1 mole 44.01. And so this, in 4 significant figures, is going to give me 11.35 moles of CO2. This is going to give me also, interesting, 11.35 moles of water. Now, there's 2 moles of hydrogen to every mole of this water, so I'm going to go times 2 equals, and that's going to give me 22.70 moles of hydrogen. Okay, we're going to come back to that. Now, we need to know how many grams of carbon there are so that we can figure out how much oxygen is floating around there. Because if we can figure out the grams of oxygen, then we can figure out how many moles of oxygen there are. So first, let's go, and we're going to take this now, and we know that this is the moles of carbon. So I'm going to change this to the moles of carbon, and we're going to go times line, and we know that the moles of carbon would give us the grams of carbon. 1 mole is 12.01 grams, and the hydrogen times line, moles of hydrogen, and grams of hydrogen. This is 1.01 for every mole. And so that's going to give us, oh, that's where it breaks down. That's going to give us 136.3 grams of carbon and 22.9 grams of hydrogen. Okay, when we add those two up, it gives us 6.3 plus 22.9 equals 159.2 grams. So now I'm going to take the original substance, which was 522.4 grams minus 159.2 grams. 4 minus 159.2 equals 363.2 grams of oxygen. 363.2 grams of oxygen. So now I'm going to come back over here and go 363.2 grams of oxygen times line, grams of oxygen, moles of oxygen, 1 mole, 16.00 grams. And so that's going to give me 22.70 moles of oxygen. Now, I'm going to ditch this part because I don't need it anymore. Now I need the moles of each of these because I get so busy here, I kind of almost forget what we're trying to do. We're trying to find the empirical formula. So we have moles of carbon, moles of hydrogen, moles of oxygen. This is the smallest number, so we're going to have 1 carbon, and I can look at this and tell you that If I divide these by this number, I'm going to have 2 of these and 2 of these, so it's going to be H2O2. CH2O2. That would be the empirical formula for number 11. And that is how you would find it. Oh, and scoring that. Yeah, that one is worth 12 points. Number 12, a compound is 19.4% calcium, and then you have the other percentages of chlorine and oxygen. What is its empirical formula? Well, we had one just like that on the review problems. So we just take this and make the 19.4 grams of calcium, and we're going to make this percentage 34.3 grams of chlorine, and then we're going to make 46.3 grams of oxygen, and then we can go ahead and figure out how many moles of each we have. Chlorine, 35 point. I should have chlorine memorized. 35.45. And calcium is right around 40. There we go. Okay, so that's going to give us 0.484, 3 significant figures. Chlorine, 0.968. And that's going to be 2.89. Okay, so you pick the smallest number of those, which is this one. And you divide everybody through by that number. And so that's going to give you 1 calcium, 2 chlorines, and a whole bunch of water. 6 waters. So that's the empirical formula. CaCl2O6. That's why. And he gives you 3 points. 1 point for turning the percentages into grams. Okay, so 3 points for turning the percentages into grams, 3 points for getting the number of moles, and 3 points for writing the final answer. You could have either had or you could have had this. Whoops. Because it's a chlorate ion. It's a polyatomic ion. But either one is correct, okay, for what you're doing. Let's see. The chemical formula for barium phosphate is Ba3PO42. For ammonium chloride, NH4Cl. For barium nitrate, well, that's it, isn't it? Okay, each question on the test.
With barium nitrate, you were supposed to determine the percent.
Oh, I'm so sorry. You are. Ha, you're right. Okay, if you, shame on me, I just wrote it down. If you did that, the percentages are, and if you need to see it, I'll do it. Barium is 52.546%. The nitrogen is 10.72%. And the oxygen is 36.73%.
Can you see the first one again?
52.546. Boy, there's 5 significant figures there. That's a bear, isn't it? And each of those answers is equally worth 3 points. Yes?
How much do you take off for missing significant figures?
Just 1. Just take off 1 point for a significant figure error. Yes?
The same thing.
1 point.
Yeah. Do you take off 1 point like per percent or just for the whole question? You take off 1 point for significant figures?
He's got them calculated as each of those answers is an individual answer. Did you miss it on each of them?
Yeah.
Just take it off once. Okay, so he's got each answer worth 3 points, and then every other answer on the test worth 3 points, but number 12 is worth 9 points. Number 11 is worth 12 points. So if you missed any of these, you got to let me know.
On number 11, I got the correct empirical formula, but my moles for oxygen were slightly off.
If they asked for the empirical formula, you skate, right? So don't worry about it. Yes?
On number 12, I only got the sub numbers switched around. So how many points do I get? On the CACL602.
What'd you do? What'd you put?
I just accidentally got them switched around.
That
I guess-
not on the list to memorize. I don't think chlorate was on the bolded
Oh, okay, but you still could have done this. Did you do this?
I did that,
Did you
but
just
I
flip
switched
them?
on the-
You switched the numbers or the whole thing?
No, the numbers.
The numbers. Take off 3 points. The whole thing's worth 9 points. Yes.
How much do you take off for putting them in the wrong order? This CL2, CA06.
You got the right numbers?
Yeah.
Don't worry about it. If you got the right numbers with the right atoms, don't worry about it. Okay? That's not what you were being tested on.